Okay, students, today we go for the sampling technique. That is, last class we have learned about the Nyquist theorem and sampling theorem, as well as we go for some maths. And today we go for the different types of sampling technique. So if we go for the different kind of sampling technique, as per your syllabus, there are three types of sampling technique. So number one, instantaneous sampling. Number two, natural sampling. And number three, flat top sampling. So first we will discuss about the instantaneous sampling. Okay, so here the name instantaneous. So first of all, why it is called instantaneous? For that we have to clarify that particular diagram or as well as the figure. So first of all, this is a continuous signal, okay, xt, and this is the del t signal, that is the impulse signal, and this is the time span 0 ts 2 ts, here also minus t, this is also minus 2t, etc, etc. Now so if we go for the two particular signal, for either it's called the multiplication, then the output or outcomes of that particular operation, it looks like that. Okay, and this is the instantaneous sampling output. And if we go for the particular circuit, this is the circuit by which we can done that particular operation. Now first of all, this is 0 and this is also 0. Always remember, this signal and this signal obviously identical almost, and that particular impulse that is inserted in same analogical way. Okay, and this is the xt signal, that is the continuous time signal, and this is the overall gt or the output signal. Now if we go for the mathematical expression, then mathematical expression is looks like that. We know gt equals to xt into that's mean that, and final, this is the output of that particular instantaneous sampling operation. Now question is that why it is called instantaneous. We know the instantaneous means very quick response. Okay, so first of all, if we go for the tau, that is the pulse width here, that is called by the help of the tau. So here tau is almost 0, that is, otherwise we should say that the instant of time it generates that particular type of waveform or sampling output. Okay, so the name of that particular technique, that is called the instantaneous sampling. Okay, so next we will go for the natural sampling. Okay, this is the circuit behind that particular type of natural sampling. Okay, so this is a circuit, this is xt, that's mean we insert here the input, and here a switching operation is there, and that is the output, and by the help of that switching operation we obviously generate a ct signal, that is called the pulse signal also. Now in that particular type of natural sampling technique, we not go in deeply about the mathematical operation, but we only concentrate on the schematic diagram as well as the output waveform. So this is the instantaneous time signal. Okay, not instantaneous, continuous time signal, and that is the ct signal. That ct is called the pulse here. Okay, now we assume the amplitude of that pulse is here a. Okay, and here this is the pulse width, that is called tau. This is the pulse width, that means it is not 0 like the previous case, and this is the time period ts. Okay, now here the operation is looks like that is xt, and that is by the help of that switch we generate the pulse wave, and output, that is gt. Now that is gt. Okay, now here the main clue is that, or main funda is that gt is equals to xt when ct equals to a. That's when this is basically it is a switch. When the switch operate, okay, So then that particular type of pulse appear. So that's been otherwise we say that when the switch is on, okay, then the A type the pulse wave with A generated, and that particular time Zt equals to Xt. That's been input and output almost equal, and Gt equals to 0 when that Ct equals to 0. That is otherwise we say that when it is the switch is off. Now if we not if we now we concentrate that particular diagram or particular output, that is the ct xt, and that is the ct. Now if we go that into that, then the outcomes or output, that is the natural sampling output or natural sampling waveform. Okay, and another thing is that here, so if we concentrate that per 3 signal, so this is my pulse signal and this is the continuous time signal. Now that signal is superimposed on that particular signal. Now as per that amplitude of that pulse is modulated. So otherwise we say that this is the one type of modulation. So obviously that particular type of modulation we discuss in our next classes. Okay, and the last technique, that is called the flat tops technique or rectangular pulse sampling technique. So here name is difficult, that is flat top. So here some meaning. So before flat top technique discussion, we concentrate the particular circuit. Here two transistor operation transistor is there, that is the xt and that is the gt. Okay, so first of all, first is called the sampling switch and second is called here this type of transistor, that is called the discharge switch. Now this is the input signal and this is the output signal. Okay, and here one important thing is that there are no particular type of on off switching option. So all that operation done that two transistor. Okay, and here one specific operation done, that is called the convolution. Okay, so everybody familiar with the term the convolution as per our signal system classes. Okay, now here that first we use the two signal. One is del t. Del t means here the impulse signal and one a pulse signal. So if we convolute the two signal, the output is obviously that particular signal and the width of that particular pulse is, that is tau. We say that. Okay, and this is the operation. Now first of all we obviously discuss the procedure, but before that, why the name is called flat top. Okay, top means the top, almost top portion, and flat top, that's been the if we go in the output portion, then the top of the output signal is looks like the flat, and this is the output of the flat top sampling. Now if we concentrate that portion, it is not looks like the previous. Okay, that portion is flat, that portion is flat. So the name of that particular technique is called flat top sampling or rectangular pulse sampling. Okay, so next we go for the particular diagram. So that is the continuous time signal. Okay, so that is the impulse signal. Okay, del t. Now first of all, that signal and that signal we go for the convolution, and obviously product is look like that output of the convolution. Now by the help of the two transistor and that signal, and by the help of that signal, if we go for the final output stage, then that is the final output. Okay, and the upper portion of that pulse here, not the discarded, is looks like that, that's been that way. Okay, that is the flat. So the name here the flat top. And here one another important thing is that, so this is TS. Okay, so this portion of obviously TS. Okay, and if the width of that particular pulse is tau, so here the width of the particular pulse is tau. So that's mean here this is the pulse signal. Okay, and obviously that input or continuous time signal is passes in that way through that particular signal. Okay, and the output of the pulse is just not modulated the previous way. That's been the natural sampling, not like that. So here the output portion, or top portion is remain the same shapes. Okay, so the name of that particular type of sampling technique is called the flat top sampling technique. Okay, and this is the final output, and this is the circuit diagram. Okay.